Holy cow, yesterday you took a ton of notes on the different types of stars. And today what we're going to do is we're going to try to put it all together in one cohesive, organized set of events. You're going to be using this note sheet, just this one page, to fill out all the information. Make sure you're filling in the bottom here. Going to be helpful for you doing your star life cycle poster to see how it all fits together. So here we go. Again, if I go too fast, please make sure that you pause it or back it up so that you can get the information that you need onto the paper if you get confused about something. Here we go. Stars are born, of course, from a nebula. They condense into a protostar, and then they become a main sequence star when fusion begins. Okay, so we'll talk about a low mass star. Again, this is a star like the sun, so a sun-sized star. Eventually, it will form into a red giant. After it stops doing hydrogen fusion, it expands into a red giant, gets unstable. And then when it runs out of helium, it puffs out that outer layer into a planetary nebula, and the rest condenses into a very dense white dwarf. And then over time, it will cool off and become a black dwarf. This, of course, is theoretical. We haven't seen one happen yet because the universe is not old enough. All right, what about a high mass star? This is one much larger than the sun. Again, 8, 10, 100, or 1,000 times as large as our sun. It will eventually do helium fusion. It will expand into a supergiant. And then when it stops doing fusion, when it reaches iron, it collapses, boom, supernova explosion. And then we get a lighter high mass. And if it's a lighter high mass star, we get a neutron star as a result, just those really, really dense neutrons all packed together in about the size of a city like New York City. And then if it's a heavier high mass star, then it will collapse and become a black hole. Crazy stuff. We do have one other type of star that we haven't talked about in this whole sequence of events. And that guy is a red dwarf, again, small, and giving off red wavelengths because it's cooler. And it takes a really, really, really long time for it to burn out and become a white dwarf. Because it is so small, it takes a long time to use up its fuel. Cool. Work on your poster.